In this lesson, we will explore concepts for how to manipulate lists and nested lists in Dynamo for Revit and Dynamo Sandbox. To begin, we're going to construct a sequence of numbers to define an x and y input of a point by coordinates node. To go ahead and do that, we'll use a double click for a code block on the canvas. Next, we will go ahead and use the search feature in the library to add an integer slider. While we're still in the search library, we'll go ahead and search for a point by coordinates node as well. And we'll place the point by coordinates node with x, y, and z inputs. We will go ahead and organize our graph in a way that makes a little more sense based on what we're trying to achieve. That includes having the integer slider over to the left, the code block in the middle, and the point by coordinates node over to the right. In the code block, let's go ahead and use the following range expression. 0, number, a to create a variable input into the code block, 1. As a reminder, this range expression in the code block will start at 0 for a count of a at an increment of 1. Let's go ahead and connect the integer slider to the a input port of the code block. And now you'll see that the code block's no longer in an error state. In order to see what is going on inside of the code block, we can hover and pin the output of the code block, or we can use a watch node. As a reminder, we can find the watch node in the library as well. Once again, you click on the watch node to place it on the canvas. And we'll go ahead and connect the output of the code block into the watch node. Now we can see as we slide our integer slider, the values will update dynamically. If we go to 50, we'll notice that we have a total number of 50 items ending at an index of 49. Additionally, in an integer slider, you can also click in the text entry field of the input and type in values. Let's type in 10. Let's go ahead and connect the output of the watch node into the x input of the point by coordinates node. We will notice that we have a change happening in the background preview window of the Dynamo workspace. Remember, you can hold down the escape key to navigate the background preview, or you can use the keyboard shortcut Ctrl-B to toggle back and forth, or you can use the icons in the upper right corner of the screen as well. Turning our attention to the background 3D preview, we will notice that we have a sequence of points that is a flat or single continuous list. Each point in the list corresponds to an item index. We can notice that if we reuse the watch node on our point by coordinates node as well. And to do that, we'll use a Ctrl-drag copy. And we'll change the input to the point by coordinates. In order to clean up our workspace a little bit, we can do that using some of the alignment commands in Dynamo. So if we select a few nodes, and in this case I'll select these first three, integer slider, code block, and watch, you can right-click on a blank part of the canvas, navigate to Align selection, and choose different alignment methods. In our case, we're going to go ahead and align to top. And now we can see that those nodes are aligned and cleaned up. We can also do this to the point by coordinates node and the other watch node. Align selection, top. And start to organize our graph in a little bit more of a pleasing way. Observing the result of the point by coordinates node, we'll notice that we have a list of points in the watch node. As we go through the watch node and click on the points, we'll see that they're highlighted in the background 3D preview as well, indicated by their index. This is for us to be able to track the geometry in the background 3D preview. Each point corresponds to an index in the list. If we want to visualize specific indices within the list, we can use another node that's available to us in the library known as getItemAtIndex. To place a getItemAtIndex node, we can use the search function. click on the Get Item at Index node in the library to place it on the canvas. Now if we connect the output of the Point by Coordinates node into the list input of the Get Item at Index node, we can start to look at how the list is structured. And we'll do that right now. We will go ahead and remove the Watch node as well. You can do this by right-clicking on the node and clicking on Remove. And we can reposition the Get Item at Index node to replace the Watch node. In order to grab an item at an index with the Get Item at Index node, we need to supply an index input. This is achieved by using an integer, which is a whole number. As you can see, we have an integer slider used early on in the graph as well. That would be the node at the very beginning. What we can do is we can hold down Control, copy the integer slider, and reuse this one to fulfill the index input of the Get Item at Index. Currently, we'll notice that the Get Item at Index node is throwing an error. This is because we're feeding it an integer that is larger than the collection of elements. And we can see that if we hover on the preview of the Point by Coordinates node. We have a maximum index of 9 and we're asking to get an index of 10, which simply does not work. To prevent this for now, we can modify the maximum range of our integer slider. That's achieved by clicking the drop-down arrow on the integer slider and changing the maximum value. Let's change it to 9. And now we can see that the Get Item at Index node is no longer in an error state and it's now fulfilled. If we hover on the Get Item at Index node, we can see which point we're selecting currently. But to make this more obvious, we can generate another piece of geometry on top of that point to visualize it in a really interesting way. Let's create a polygon to more clearly view this isolated point. To do this, we need to look at some of the geometry libraries available to us in Dynamo, and we can do that in the library. In order to get started, we're going to create a circle. The way that we can do this is by using a center point and a radius. Browsing the node library, we can click on the Geometry library, Curves, Circle, and find the node by center point radius. Click on the node in the library to place it. As we can see, the Circle by center point radius node already defined a circle in the background 3D preview. This is because the inputs of this node already have a default value, and we can see that by hovering on the input port. So the point has a default value of 0, 0, 0. Additionally, the radius has a default value of 1, and that would be a double, which is also referred to as a number. In order to utilize this node efficiently, let's plug the output of the Get Item at Index node into the input of the Circle by center point radius defined center point. Very quickly, we can see that we are now essentially circling the point that we're obtaining with the Get Item at Index node. Really quick way of visualizing this. In order to define the radius of the Circle by center point radius node, we can use a number slider. Let's go ahead and search for that in the library as well. Placing a number slider, we can move it towards the input and plug it into the radius input port. We can also go ahead and navigate our background 3D preview to better isolate the view so that way we can see what's going on. So now that we have the number slider placed and plugged into the input port of the radius of the Circle by center point radius node, we can drag the slider and see those changes update dynamically as well. Currently, the number slider has very large values, so we can make the circle up to 100 on the output. In order to make this a little more functional, we can change the maximum and minimum values once again. Let's change it to a maximum of 1 and a minimum of 0 for now. And now we can change it to a value that makes a little more sense to see what's going on in the background preview. Any value less than 1 should do. I previously mentioned that we're going to use a polygon to identify the selected point in the background 3D preview. So let's go ahead and construct the rest of the polygon. We'll go ahead and navigate to the library, go to the Geometry category, Curves once again, Polygon, and we can see that we have a node called Regular Polygon. Let's go ahead and place that node on the canvas. As we can see, this node takes a circle as one of the inputs and a number of sides as the other input. We can go ahead and fulfill the circle input with the newly created circle from our previous node that we placed. Holding down Escape, we can zoom into the background 3D preview as well. And right-click to orbit. Now we can see that we have a polygon constructed on top of that circle. By default, the regular polygon node has a value of 5, which is also an integer or a whole number. In our case, we want to change this to a diamond shape. So we can do this by using a number of 4 and inputting that into this input port. To do this very quickly and easily, let's double click for a code block and type in a 4 and use that output to fulfill that input of the number sides input on the regular polygon node. Code blocks are a really nice way of also entering numbers very quickly. As you can see, we now have the circle and the diamond showing in the background 3D preview. Since our end goal was constructing a diamond shape to be able to preview the point, we don't want to see the circle anymore since we're using it downstream for something else. Since we're just using it as an input for the regular polygon node. In order to hide that geometry, we can right-click on the circle by center point radius node and change its preview to be off. Now we can see that we only see the regular polygon showing in the background 3D preview. Any node in Dynamo that shows geometry in the background 3D preview can be toggled off in this manner. Now we would like to modify our structure of points in the background. In order to do this, we can redefine some of the values in the point by coordinates node that we placed originally. So we'll go ahead and pan back to the beginning of the graph and reorganize our data to be able to do this. We'll go ahead and remove the watch node, right-click, remove, and reconnect the output of the code block to the X value of the point by coordinates node. I'm also going to reposition these nodes to better influence how the flow of the graph should work. We will also unpin this preview if you still have it pinned. In order to modify our list of points in the background 3D preview, let's go ahead and copy the integer slider and the code block. We'll go ahead and do this with a control drag copy. We'll hold down the control key with both nodes selected, click on a node, and simply drag to place the new instances. The output of these nodes will go into the Y input port of the point by coordinates node. As you can see, the background 3D preview has now updated to give us an angled list of points. Once again, you can observe this by clicking on the background 3D preview navigation button in the upper right corner of the workspace. And we'll reposition it to be able to see it a little better at this point. Navigating the 3D background preview and the node canvas in Dynamo is really important. There's not really a perfect way to position everything to be able to see it all at once, so being able to seamlessly navigate is key. In order to get a grid of points, we need to change the lacing of the point by coordinates node. Once again, lacing options can be found by right-clicking on the node, navigating to lacing, and changing it in the flyout menu. In our case, we want cross product. And as you can see, the background preview is updating dynamically. We're still generating our polygon on the list of points that we're selecting. Navigating our graph, we can see that we have a new output of the point by coordinates node. What we now have is a list of lists. As always, in the bottom right corner of the flyout menu, we can see how many items total we have being created with the point by coordinates node. If we navigate over to the left, we'll see that we have individual lists of 10 items. This represents the columns within that structure. So as we click on these points, we can see their index highlighted in the background 3D preview. So in our case, we're working through the columns currently. In order to better illustrate what is going on inside of this node, let's use another node that's available to us in the library. if we navigate to List, Inspect, Count, we can place a very unique node that will return a count of a list to us to be able to see what's going on. We'll go ahead and connect the output of the point by coordinates node into the list.count node. And once again, if we hover, we can pin the output to be able to visualize what this node is doing. As we can see, the list.count node is telling us that there are 10 items that exist in the input of the list.count node. This input corresponds to the output of the point by coordinates node. If we navigate the point by coordinates node preview, we can see that we have the sublist with these little arrows to click on. As you click on these arrows, we can see how many sublists we have as well. And we'll go through and click these. So we have a total number of 10 sublists, starting at 0 and ending at 9. Keep in mind, everything in Dynamo is 0 index based. So when you see it ending at the index of 9, that's 10 items. If we want to see how many items we generated per sublist, that is doable with the list.count node as well. If we zoom in on the point by coordinates node output, we'll see that we have some more values in the bottom left corner of this preview. We have these @ symbols with the letter L and a number next to them. This represents levels of the nested list structure. In our case, we have a very outer level of L3, an inner level of L2, and the innermost level of L1, which represents each individual point. By default, the count node is counting at level 3, so the very outside of the list. So if we were to come in to the preview of the point by coordinates node, we'll see that the count node is in fact counting the sublists. In order to count the nested list and the items within them, we can use a feature in Dynamo called levels. In order to access the levels of the list, we can click on the little arrow on the node and click on Use Levels. So right when we click Use Levels, we can see that the list.count node is now counting the points within the nested lists, and that would be at L2. So by default, we're at L3, and then we jump down to at L2 upon activation. Additionally, we have some new arrows that showed up in the UI to be able to toggle which way we're counting. So understanding that basic overview of the nested list structure, we can continue on as well. So we'll go ahead and unpin the list.count and unpin the point by coordinates node. So now we have an understanding of how we're counting the individual points in the nested list as columns. Let's go ahead and switch the columns and rows around and see how that looks. As you can see in the background 3D preview currently, I still have the coordinates showing, so the indices of the specific points. If that ever happens, it's simply because we clicked on the list within the node. In order to hide that once again, we can simply right-click on the node and toggle the preview back and forth. And now you can see that all of the indices are gone in the background 3D preview. In order to switch the rows and columns in our nested list of points, we're going to use a new node called Transpose. In order to use this node, let's go ahead and remove the list.count node and then search our library for Transpose. Place this node on the canvas and drag it to the right of our point by coordinates node. Let's go ahead and plug the output of point by coordinates into the list.transpose node. And in order to see what's going on in the background 3D preview, let's use the output of the list.transpose node as the input of the getItemAtIndex node. Navigating the background 3D preview, we can see that the result has changed pretty significantly. So rather than selecting the last column of the list, we're now selecting the last row of the list. And that's because we flipped the values. So switching between columns and rows can be achieved through the list.transpose node, and we can still visualize those results using the nodes that we had placed previously, which were the circle by center point radius and the polygon.regularPolygon node.